Hello algebra students, in this video we are going to practice working with equations, and remember these are the easy one-step equations, so there's only one step to solve them, and we're going to be using addition and subtraction as our operations. Also remember, we're going to be keeping in mind that we need to use an inverse operation to get the variable on a side all by itself. That's what we want to do. Get the variable on a side by itself. If the variable's on a side by itself, we know what the variable equals. But A and B don't call for that. Letters A and B are actually a little bit easier. These ones are just checking whether we can evaluate an expression on one side of the equation, and then we're going to check to see if that evaluated expression actually does equal the thing on the other side. We haven't done this yet. The closest thing we've done to that is evaluating expressions on either side of a inequality symbol, like less than, greater than, or equal to. That was kind of like what we're doing here, but this time we're only looking for one thing. We're looking for expressions that equal each other on either side of the equal sign. So the question is, does the expression on the left equal what's on the right? Well, let's find out. H minus 14, and we're going to plug in 12 for h. So we're going to do 12 minus 14. Well, 12 minus 14, let's see, the question is, does it equal 2? 12 minus 14 is actually negative 2. And negative 2 is not equal to 2. So the answer to the first one is no. That value is not a solution to the equation. Letter B. Negative 11 equals j minus 4. Well, let's just test this out. Negative 11 equals, does it? And j is negative 7, so negative 7 minus 4. Well, let's think about that. Negative 7 is negative. Minus 4 is the same as plus, the opposite of 4. So those are both negatives. That means that I add the values and then keep the sign. 7 plus 4 is 11. I keep the negative sign, negative 11. So when I work this out, I get negative 11 equals negative 11. That is a true statement. So yes, j equals negative 7 is a solution for the equation because I actually get negative 11. All right, let's work some actual equations the way that we work equations. X minus 5 equals 17. All right, so here's what we're going to do. We need to get x on a side by itself. But right now, x is having 5 subtracted from it. What is the inverse of subtraction? Why, addition is the inverse of subtraction. So if I add 5 to x minus 5, that's going to change it to x minus 5 plus 5. That gets x by itself because it gets rid of the 5. Minus 5 plus 5 is just 0. But I can't just add 5 to one side of the equation. I have to add 5 to both sides of the equation. So what do I get then? X minus 5 plus 5, which is just x plus 0, equals 17 plus 5 is 22. So x equals 22 is the solution for C. X equals 22 is an equivalent equation to x minus 5 equals 17. How do I know it's equivalent? Well, I just added the same thing to both sides. That doesn't actually change the truth of the equation. It does change the equation to a different equation, but it's an equivalent equation. It has the same outcome. That's what I need to do. I could easily go back and check my work by just plugging in 22 for x like we did in A and B. 22 minus 5 is 17. This is a solid answer. Let's go on to letter D. In letter D, we have negative 30 equals m minus 12. Here I'm going to use the inverse of subtraction, and instead of subtracting 12, I'm going to add 12 to both sides. M minus 12 plus 12 is just m. I'm going to have m on one side by itself. Doesn't matter that it's on the right side. And then over here, I'm going to add 12 to this side also. Okay? So I added 12 to both sides. That's a perfectly legal move in algebra. Let's see. Negative 30 plus 12, I have different signs on negative 30 and 12. So that means I'm going to find the difference, 18, and I'm going to keep the sign of the one that's bigger. Negative 30 is bigger than positive 12 when I'm talking about the absolute value. So I'm going to keep the negative sign. So it's going to be negative 18 on this side equals m, because m minus 12 plus 12 is just m. We use the inverse operation and get rid of the 12. So negative 18 equals m. That's the same thing as m equals negative 18. I'm going to rewrite it, but you don't have to. If you have negative 18 equals m, that is a perfectly valid answer because m is on one side by itself. Even if it's on the right side, that's fine. A little cleaner if you put it on the left side. A little more correct, I guess, as far as what you would normally see, but this is okay too. All right, let's just go back and double check. Negative 18 minus 12, does that equal negative 30? Yes. So letter D is correct. Let's go on to letter E. It just says solve. We don't have to check our solution anymore, but it is such a good idea to check your solution anyway. P plus 3 equals 37. All right, so what I'm going to do, I'm going to use the inverse. I'm going to subtract 3 from this side, subtract 3 from this side. That's going to give me P, okay, by itself, because that plus 3 minus 3 is just 0, equals 37 minus 3. What is 37 minus 3? Why, that's 34. So P equals 34. Let's just go back and check. 34 plus 3 equals 37. Is that correct? That is absolutely correct. On to letter F. All right, letter F. Negative 14 equals y. Oops, hold on. That's not right. 14 equals y plus 8. I'm going to subtract 8 from both sides to get y on a side by itself. And what am I going to be left with? Negative 22 equals y plus 8 minus 8. Why, that's just y. Y equals negative 22, or negative 22 equals y. Let's go back and plug that in. Negative 22 plus 8 is negative 14. Negative 22, I find the difference between the two is 14, and then negative 22 has a larger absolute value, so I keep the negative sign. That is a solid way to solve that. Let's go to, a hard one, G. G, I have D plus 4 1/2 equals 3 1/6. Okay, now, I'm going to do it this way. I'm going to subtract 4 1/2 from both sides because it is perfectly legal to do so. So 4 1/2, and then I have to do the same thing to the other side, minus 4 1/2. Okay, so what am I left with? Now, here's one where it's helpful to just draw out the intermediary. So it's going to be 3 1/6 minus 4 1/2. Now, I can't just do 3 1/6 minus 4 1/2. What I need to do is multiply. 6 times 3 is 18, plus 1 is 19. So here I have, I'm going to change these all to improper fractions. D equals 19/6 minus 2 times 4 is 8, plus 1 is 9. This is going to be 9/2. So I changed them to improper fractions by just multiplying the denominator by the whole number out front and then adding the numerator. And then it's all over the denominator. So 19/6 minus 9/2. I need a common denominator in order to do this subtraction problem. That's what makes this hard. Whenever I have fractions, I need a common denominator on my fractions. My common denominator, though, could just be 6. Because 9/2, if I multiply the bottom by 3, I get 6. I multiply the top by 3, I get 27. So 9/2 is the same as 27/6. And now I can just subtract. 19 minus 27, 19 minus 27, that's going to be 19 plus the opposite of 27. So I find the difference between the two, which is 8. And then I keep the sign of the one with the larger absolute value. It's the negative one. So it's going to be negative 8. And then I just keep my denominator, which is equal to negative 4/3, or 1 negative 1 1/3 would also work. But negative 4/3 is a perfectly fine answer. I actually prefer it as an improper fraction. All right, that's how we do that one. Now, let's do letter H. In letter H, Jagdish took the same test twice. On the second test, he scored 87, which was 13 points higher than the first test. What was his first test score? So what we need to do is come up with an equation that relates the second test to the first test. And here's how we're going to do that. F plus 13. So F is going to be his first test score, plus 13 points higher than, so we're 13 points higher than the first test gives us the second test score. So that F plus 13 equals 87. This is going to be the working equation. Now, how am I going to solve for the first test score if F plus 13 equals 87? Well, I can just subtract 13 from both sides of this equation. If I subtract 13 from the left, I get F plus 13 minus 13. That's just going to be F. And then I have 87 minus 13 on the right-hand side. So I'm just going to go ahead and do that. F equals 74. 87 minus 13 is 74. That means that Jagdish scored 74 on the first test, and then the next one was 13 points higher, which is 87. I just checked my work, and that totally makes sense. All right, and that is how you work these problems that are one-step equations with addition and subtraction. You probably saw that throughout this, it was really easy to do these, and as you do the problem set, when you come to these problems, they're really not that hard. So you should be able to do problem set 1 through 30 for next time.